When you're working with random variables, sometimes you're going to have to apply linear transformations to those variables, and in other situations you're going to want to combine random variables together. And in these two situations, you need to know what happens to the means and the variances as a result of these linear transformations or these combinations. We use the linear transformations when we change units of measurement. It might happen when you're changing the quantity of goods sold to the dollar value of those goods by multiplying by the unit price. That happens in business quite a bit, but this happens in lots of situations. So in this video we'll look at how you alter the means and the variances of the random variables you're working with when you do that sort of transformation. Now you might remember from an earlier unit that when you do a linear transformation to data, what happens to the measures of center and spread depends on what kind of transformation you perform. If you add a constant to all of your data values, that just changes the center of the distribution of your data. It doesn't do anything to the spread. If you multiply all of your data values by a constant, that affects all the measures of center. It also affects the spread of your distribution. And similar things happen when you're working with random variables. Adding a constant to your all the values of your random variable will just change the center, that is the mean of your random variable, but it won't change the spread. But if you multiply your random variable by a constant, then your mean and your standard deviation will change accordingly. So we'll look at these in more detail. If you apply a linear transformation to a random variable x, a plus bx, so we're changing x to a plus bx by multiplying x by something and then by adding something else onto it. The mean of the transformed variable is equal to a, the constant that you're adding, plus b, the constant that you're multiplying by, times the original mean. That's the rule that applies for means. The variance of a plus bx is going to be b squared times the variance of x. You notice that this particular expression right here does not contain an a. That's because this a just affects the center. It does not affect the spread. So that would not enter into the new variance. And the standard deviation is the square root of the variance. So that's just going to be the absolute value of b times the standard deviation, the original standard deviation of x. This has to be an absolute value because in some situations b might be a negative number, but you want to take the positive square root of b squared when you do this because the standard deviation can never be negative. So you always want the absolute value of that b times the original standard deviation. Here are some examples. We have a variable x with a mean of 60 and a standard deviation of 15, and a variable y with a mean of 16 and a standard deviation of 4. To find the mean and the standard deviation for these transformed variables, we just apply the rules. The mean of x plus 30 would be the mean of x plus 30, and that's 60 plus 30 or 90. The standard deviation of x plus 30 is just the original standard deviation of x, which is 15. Adding a constant has no effect on spread. If you subtract a constant from your random variable, that should not affect the spread either. If you transform the variable y into y minus 7, the mean will change. It'll go down by 7. What was 16 now becomes 9, but the standard deviation will stay the same at 4. It won't be affected at all. So subtracting a constant has no effect on spread. If you multiply your original variable by a constant, in this case 4, the mean of 4x would be 4 times the original mean of x, and 4 times 60 is 240. The standard deviation of 4 times x is just going to be 4 times the original standard deviation of x, and 4 times 15 is 60. If we do both of these transformations, where we multiply our original variable by a constant and then subtract or add a constant onto that, we'll see a combination of these effects. The mean of 3y minus 5 is 3 times the original mean of y minus 5, and that would be 3 times 16 minus 5, which is 43. The standard deviation of 3y minus 5 is just 3 times the original standard deviation of y, which is 3 times 4, or 12. Again, that adding or subtracting a constant has no effect on spread, so this minus 5 will not affect the spread. Here are some examples you can try on your own. we have these transformed random variables. Use the same original means and standard deviations from up above and see what happens to the means and standard deviations when we apply these transformations. So you can take your time and restart the video when you're ready, and the answers will show up on the next page. Okay, welcome back. Here are the answers. If you subtract 12 from x, the mean of x minus 12 is going to be the original mean of x minus 12. That's 60 minus 12, or 48. The standard deviation of x minus 12 is just the original standard deviation of x, which is 15. Again, subtracting a constant has no effect on spread. If you add 15 to y, the mean of y plus 15 is the original mean of y plus 15, which would be 16 plus 15, or 31. The standard deviation of y plus 15 is just the original standard deviation of y, which is 4. The standard deviation will not change when you add a constant. If you multiply x by 0.5, the new mean is going to be 0.5 times the original mean, and 0.5 times 60 is 30. The standard deviation of 0.5x is 0.5 times the original standard deviation of x, and 0.5 times 15 is 7.5. If you transform y by multiplying it times 5 and then adding 10, the mean of 5y plus 10 is going to be 5 times the original mean of y plus 10. 5 times 16 plus 10 is 90. The standard deviation of 5y plus 10 is going to be 5 times the original standard deviation of y, and 5 times 4 is 20. If you transform x by multiplying it times 0.6 and then adding 5, the mean of 0.6x plus 5 is going to be 0.6 times the original mean of x plus 5. 0.6 times 60 is 36, and 36 plus 5 is 41. The standard deviation of 0.6x plus 5 is just 0.6 times the original standard deviation, which is 0.6 times 15, or 9. That plus 5 makes no difference to the spread. It only affects the center. So remember the general rules. Multiplying your random variable by a constant changes both the mean and the standard deviation by the same constant. If you add or subtract the constant to your random variable, that will only affect the mean by the same amount. It will not affect the standard deviation at all. If you remember those two rules, then it's pretty easy to apply these linear transformations to random variables, and you won't have too much trouble.